Hi, and welcome back to Google Cloud's Global Digital Conference, the future of your data warehouse. My name is Han, and today we'll be talking about how BigQuery can be a perfect companion to your data lake. At any time during our live session, you can ask questions on our platform, and Googlers are standing by to answer them. So let's get started. In today's agenda, there will be three parts. There will be some slides, there will be a demo right in the middle, followed by an actual customer use case sharing from Pandora. And I'll be doing that on their behalf, of course. So without further ado, let's go. So why are we here today? You've been hearing about data is exploding, but here are some numbers. So according to IDC, we're going to be generating, as a human race on this planet, 175 zettabytes of data by 2025. So forget about gigs, forget about terabytes, forget about petabytes, forget about exabyte. We're going to zettabytes. So how are we going to capture that information in a meaningful way, in a fast enough way, and be able to act upon that data so that it can actually bring some valuable insights? So let's talk about the data lake. You've been hearing about the concept of a data lake for the entire conference since we started. So it is both a concept and a platform, right? So as we know, data is growing, but the type of data is also changing. So traditionally, we have very structured data in table formats, in databases, and all that. And then when we move to NoSQL, and then now we have data captured in CSV files. And then now with unstructured data, it could be a digitized picture of an invoice. It could be a video feed. It could be an audio feed. And so we got to find a way to bring it all together in this data lake platform, where we are able to ingest, store, process, and analyze it in a meaningful way. We're talking about analyzing and ingesting. We no longer have the luxury of batch. So gone are the days where we can wait for 6 hours, 12 hours, 24 hours for data to come in, go through a series of transformation, and then we derive some insights. There are certain data sets that we need to collect in near real time or real time and act upon them in real time as well. So the data lake platform needs to support both batch and real-time streaming. Now, because of the different types of data, type formats that we have, we also need to cater for SQL, which is a traditional, very tried and tested, well-defined paradigm, all the way to machine learning, AI, and search. So you must be able to convert and capture metadata from unstructured data sets, analyze them, search through them, glean certain patterns from them, and then derive a machine learning model so that you can apply to new incoming signals, whether it be from your customers or from your partners. And finally, a data lake is a place. It can be on-prem, it can be on the cloud. And because we're in Google Cloud, we want to talk about what we can do with a data lake concept as a platform in our Google Cloud platform. So why are customers coming to Google Cloud? Over here, you see on the screen 4 attributes. So Google Cloud is scalable. It has inexpensive storage. I would add inexpensive compute as well, because we're in a cloud model where you pay only when you need the CPUs and not commit to a CPU for years and years and years, right? We provide a serverless data analytics platform, so we no longer need to worry about planning out how big your cluster is. Oh, I've run out of disk, oh, I've run out of CPU, how do I add it? That's a lot of plumbing. And especially for customers who is not in the business of IT, but in the business of data and bringing insights for their business, this can be a very laborious process, and they're happy to offload it to us. And finally, with our innovative AI and ML and the way we secure our data, customers are coming to Google. So with that, let's take a look at the Google Smart Analytics platform. Now, looking at the blue color bar, we basically separated our first party, with the exception of Confluent, of course, it's third-party software, into collect, which is where we ingest data, process, where we do some wrangling, transformation, storing data in an efficient format, analyzing it, and then exposing that to business intelligence and vertical applications. Everything in the yellow boxes are what we have today that will supercharge our data lake or your data lake on Google Cloud Platform. Now, having said that, you do not need to use every single product and service in that yellow box, in the yellow boxes there, that's when you actually come to our Google Cloud partners and our Google Cloud customer engineering team, where we sit down and consult with you and figure out what is the best approach and to stage your migration into Google Cloud. Now, this diagram is incomplete because there are lots of third-party software that we are in partnership with and that can integrate with our first-party software and services inside Google Cloud. Because Google is very pro open source, so Confluent, Kafka, DataStax, and of course the well-established brands out there like SAP, IBM, Tableau, Qlik, you name it, we have the connectors to those software as well. So let's talk about the migration phases or the migration paths and options. On the left is lift and shift, and on the right is building a cloud native and leveraging the best of what we can give to you from Google. Because all the technologies that Google uses, we are simply externalizing it as a service to our customers. On the little radios, you will see low, medium, and high. Here we talk about the efforts and the benefits. A lot of customers will use lift and shift as an initial strategy to move and offload their compute and data into Google Cloud because we can handle bursty workloads. We go pay as you use, and we support a lot of open source as well as commercial software running on our cloud. But the benefit is low because in our conversations with customers, lift and shift is never a long-term strategy. It is a short and mid-term strategy to move things quickly to the cloud, and then we look at transforming what they've got into something that's more cloud native, that is even more efficient and even more flexible, leveraging the services. So the second option is to identify a single workload. Here your effort goes up a little bit, but the benefit is higher because you are able to identify a subsystem that you can move quickly to GCP, leveraging some of our best technologies and able to have results, tangible business results in a short amount of time. So we've seen anywhere from 1 month to 4 months where the proof of concept or little pilot can complete and you can see the value, and then we can continue to evolve the project and conversation. And finally, for those who are really convinced, they will just come right in and start using our cloud-native solutions, running it in parallel with their production systems, and when it's right, they simply switch over. So when it comes to data lake, right, one of our premier and very popular service on Google Cloud is Google BigQuery. Google BigQuery is Google Cloud's enterprise data warehouse platform. It is exabyte in storage, petabyte in queries. It is Google Secure, where every piece of data that comes into Google Cloud is encrypted in transit automatically, and every piece of data that eventually lands on a storage is encrypted automatically. In fact, there is no option for unencrypted data storage or unencrypted data access in Google Cloud. And on top of that, we also allow you to bring your own encryption keys, just in case you don't want to use our Google supplied encryption keys, which is randomly generated anyway. So Google Cloud BigQuery is a serverless platform, which means that when you start your BigQuery service, you do not need to plan ahead of time how much CPU, how much storage, how many nodes, how big is your cluster, what is your backup strategy, how do you do stepwise software upgrades. None of that. You just bring the data and you bring your queries and we will sort it out all for you because it is truly, truly serverless. In fact, it is so serverless that our compute platform for running your queries is totally separated from the storage platform that stores your data. And we will show you that in the demo that's coming up very shortly. It allows real-time insights because BigQuery supports streaming inserts, which means that a live stream coming from your users going through some form of transformation or streaming analytics, and it can be streamed straight into BigQuery, where your SQL queries can act upon the data immediately. And finally, the last 2 points, we built in machine learning and geospatial capabilities inside BigQuery as well, which means that traditionally you need to take data out of the BigQuery or any data warehouse, run it through some machine learning, learning and processing and predicting process, and bringing the data back in. You don't need to do that anymore. So in BigQuery, using SQL alone, today we support linear regression, logistical regression, and k-means clustering. As Jordan has shared earlier in the keynote, we are actually supporting even more models in the coming days very soon, like XGBoost. And finally, we have a new beta feature that is out in a while now. It's called the BI engine. It is an in-memory system. Today, as part of the beta, you can preload curated data sets into the BI engine, which is an in-memory system, and then expose that as a data source to your BI tools. Today, we support Google Data Studio. In the coming weeks, you'll be hearing a very positive news about connected sheets. And then further on in 2020, we'll support even more third-party BI tools using that feature. Now, let's talk about the migration options. And this is a lead-in to our demo for today. In Google Cloud, you can put data in Cloud SQL, which is your traditional RDBMS. We support MySQL, PostgreSQL. For NoSQL, we have Bigtable as well as other flavors. If you have it in a kind of a spreadsheet format, you can kind of upload it into Google Sheets. And of course, we have the ultimate Swiss Army knife storage called the Google Cloud Storage, where you can store virtually anything, from a PDF file to unstructured data like JPEGs, movie file, audio streams, CSV files, JSON, and of course the open source supported the Apache Avro, Apache Arc, and Parquet formats, right? You can also upload data into BigQuery storage. Remember, BigQuery I mentioned earlier is serverless, so it has both a storage as well as a compute and query engine component. So here we're simply talking about the BigQuery storage. You can upload data in tabular format, semi-structured format with JSON as part of the fields. And of course, over there, we have non-BigQuery analytics. The top two logos are basically Dataflow and Dataproc. Dataflow is basically a managed runtime for open source Apache Beam, and Dataproc is a managed runtime for open source Hadoop and Spark. So you can use our service, or you can bring it your own and run it on your VMs. But today we want to announce a BigQuery storage API. This is something that our customers have been waiting for, and we're happy to announce it. So this is a way for us to expose the BigQuery storage as a first-party data source to external query components. So I may not choose to use BigQuery to query the data that's in the BigQuery storage. I could actually offload this to Spark because I may have a more complex workflow. So if you can see my screen, I am looking at the bit.ly link for the code lab for PySpark for pre-processing big data query. So I need to show you what's happening in BigQuery. Then I'm going to show you what's happening in Cloud Dataproc, right? So let me switch over to BigQuery really quickly now. So in BigQuery, I have a data set. I have Reddit posts from year 2016 every month all the way through to this year, 2019. So I'm scrolling down. You can see it goes to the August of 2019, right? So I can tell you now the average monthly table here is about 3.77 gigabytes and about 6.8 million rows per month. And of course, over time, that number increases because more and more people is coming online and participating in Reddit. So by 2019 and 2008, the table size is actually 10 gigabyte, and we have about close to 22 million lines or rows of data, right? So within the schema here, you can see that there's this thing called a subreddit, which is like the category of which people are posting their queries and their comments. And of course, I'm going to show you a little simple SQL query up here. I'm going to try and zoom in for those who are watching. OK, so I'm going to select subreddit count star as hits from Reddit demo. And notice I'm in BigQuery, you can use an asterisk. So every table name that starts with 20, so 2016, 2017, will be done. So we'll run this query across multiple tables in a single query. We are going to group by subreddit, and we're going to order by the hits in descending and limit to 20. Now I'm going to start to run this query now, all right? And you can see the processing location is in Asia Southeast 1, which is here in Singapore. Now, a lot of our demos have all these data sets in the US. I wanted to bring this closer to home because this is the APAC region. So we are running this off of the Singapore data center. So I'm going to click the run button. How long do you think it will take? Oh, it's fast enough for me to finish a sentence like in 2 seconds, and then it's done. So in 2 seconds, it has queried 6 GB of data because it's columnar store. If you look through the last 3+ years of data, we have about 271 GB of data. So the top Reddit is Ask Reddit, followed by Auto Newspaper, followed by the Donald, and the hits. That's the most important thing that I want to bring your attention as part of this demo, which is this number. We will come back to this number very shortly. So now we've done this simple query in BigQuery. Now, how would you do this if I'm doing this from Hadoop and Spark? So that's where I come into the next part of my demo, which is Cloud Data Prog. Cloud Data Prog is a managed service for Hadoop. And over here, you can see that I have a cluster already running, right? I want to quickly switch over, and let me quickly submit a job. OK, let's submit the job first, and I'll talk about it. So on the bottom, you can see that I've submitted a job. Now, we can do this interactively using the web GUI, but I want to speed this up, so I put the scripts in there. So over here, I'm going to zoom in and show you what the submit job does. It tells Dataprog that I'm submitting a PySpark job to my Singapore cluster. Bucket is basically my Google Cloud Storage output. The jars, that's interesting. Why do I need to put a jar there? Because I am using the BigQuery storage API as a library in Spark. So that's where the library is, right? I specify the region to be in Singapore, and I run the job, and the content of the job is called counts by subreddit-sg.py. So at the bottom, you can see the job has already kicked off. Let's look at what this thing does. I'm going to take advantage of the Cloud Shell's GUI component, right? So here, you can see that, OK, I'm going to import all the libraries. Most importantly, I'm creating a data structure, right, called subreddit and count. And then from there, I create a data frame that's going to keep accumulating the counts. I then specify the years and the months that I'm interested in. And then I go into a loop. And here is the name of the table. This is the same table format as BigQuery. And the most important bit is this line here, that it's going to read from BigQuery as a table and do a load. Now, this calls on the API inside the BigQuery storage API, and then the data is going to come in fast and furious into my Hadoop cluster. So data is coming straight from BigQuery storage itself, right? So, it looks like the job is completed, which is fantastic. OK, let's have a look. We go to jobs. Yep, the latest job is completed in 1 minute and 51 seconds. If I go into web interfaces, we can click on the Spark history server, which I've already opened here. Let me do a refresh to see if the job has completed. Yep, job number 7 has completed in 1.3 minutes according to the Spark history server. Let's click into it and have a look. The event timeline, and you can see quite a number of worker nodes are running to get this thing done. Right, so with that, before that, let's verify, shall we? Let's look at the results. The results from, zoom in. Right, so it's exactly the same number you saw in the BigQuery query, right? So that proves that you can have access to the same data, right, with 2 different types of compute engine and going to the same data set. So let me switch back to my presentation. Right, so let's do this the other way around. So I can expose my BigQuery storage to external devices or external services. Likewise, BigQuery can also read as a table data that's hosted outside of BigQuery storage. So today, we are very pleased to announce that very, very soon, in the next couple of days or even a week, we will have public beta ability to create BigQuery external tables to Apache, Orc, and Parquet formats. So you do not always have to bring the data into BigQuery before we can act upon them, right? So that's coming very soon. Now we're going to move into the part where we talk about our customer use case, and in this case, it would be Pandora and their migration journey into Google Cloud. So for those of us who may not be familiar with Pandora, who's outside of the US, Pandora has been around for close to 20 years. It is the leading music and podcast discovery platform. It's streaming music and podcasts to their members. They have over 64 million users per month. They support over 2,000 different devices. 13 billion stations has been created by the end users, and they've collected over 90 billion thumbs. So a thumb in Pandora is a user input, a comment, right? And basically, we're able to capture a lot of preferences. They've got lots of data. So they started moving to Google Cloud in 2018, which is just 12 months ago. But before they come up to Google Cloud, they had about 2,700 nodes of Hadoop on-prem. That is a lot of VMs, right? And a lot of energy and process to manage them. There are 7 petabytes of stored data across 130,000 Hive tables, thousands of daily queries, most of them scheduled, and of course some of them are ad hoc. And of course, they mentioned something about some three Kafka clusters for real-time streaming ingestion as part of their IT systems. Now, when they look at their overall IT systems, they're able to categorize broadly 3 users and use cases. Analytics. These are where you collect business intelligence from your users. You quantify your product, you create reports in a heat map, usage, and then in the middle we have data science. Data science is basically taking all the past historical data and user preferences, do some aggregation and try to figure out what is the next best station, the next best podcast, the next best music to recommend to your user based on past data and similar user profiles. Right? And finally, we have the production systems which are on-prem to support that, and of course, their real-time system pushing advertisements and supporting that streaming service. So why did they come to cloud? 2 main things, flexibility and efficiency. They no longer need to commit 3 years upfront to hardware, which is really hard to predict. They have a lot of bursty workloads, as you can imagine, based on their use case. They also want to use managed services, and they don't want to be experts in all the IT plumbing and happy to offload that and spend their energy on finding data and data insights. So really the decision to come to GCP is our Google's distributed computing expertise, as well as our AI and machine learning focus. So let me skip right through, because of time, to the results. So impressions by ad per month. Previously on-prem using Hive and Presto, they're able to improve from 30 minutes to under 20 minutes, but with BigQuery, they're able to do it in under 21 seconds. As you can see on the rest of the tables, we're moving from minutes to seconds. That's orders of magnitude of improvement. The faster you can ingest data, the faster you can act upon data, the faster you can gain business insights and then act upon them to improve your business as a result. So with that, start thinking about the different advantages of using federated approach in moving data to the cloud, first to GCS, sometimes maybe through streaming straight into BigQuery. We can do this in multitudes of ways, but of course, the Google Cloud Engineering is here to support you. Thank you for spending time with me in this live session. We have talked through Data Lake, BigQuery, demos, as well as a customer reference.